Year 10 half-term homework work solutions. Question number 1. You had to label each of the parts of the circle using the words provided. This point over here is the centre of the circle. This line here is the radius of the circle. This line here is what we call a chord, which passes from one point on the circumference to another point on the circumference. And this straight line here is described as a tangent. It's a line that touches the circle at exactly one point only, so it can't cross the circle. Now, one of the lines wasn't marked, which is the diameter, so if we just draw one in from circumference to circumference, passing through the centre, this dotted line is the diameter. Calculate the area of this semicircle, which has a radius of 10 centimetres. So we know the area of a circle is equal to pi r squared, which is pi times 10 squared, or 100 pi. So the area of the semicircle is exactly a half of this. So we take 100 pi and we divide it by 2, which gives us an answer of 50 pi centimetres squared if we leave our answer in terms of pi. If we want to convert our answer to a decimal, that works out to be 157.079 ... which we can round to 157.1 centimetres squared to 1 decimal place. Question 3. Work out the circumference of a circle which has a diameter of 10.5 centimetres. So making sure that we use the correct formula, the circumference is equal to pi multiplied by the diameter, which is pi multiplied by 10.5. If we want to write this in terms of pi, that is 10.5 pi. If we work this out as a decimal using a calculator, this is 32.986 ... which is 32.99 centimetres to 2 decimal places, or 33.0 centimetres to 1 decimal place. Question 4, part A, factorise x squared plus 10x. We factorise this as x bracket x plus 10. A quick check by expanding back. This is x squared and this is 10x, so we know we are correct. Part B, factorise y squared minus 36. We should recognise this as a difference of two squares. And we know that a general difference of two squares, for example, a squared minus b squared, factorises as a minus b, a plus b. So we can factorise y squared minus 36 as y plus 6, y minus 6. Question 4, part C. Solve this equation. The first thing I'm going to do is add w to both sides, which gives 6w plus 6 equals 9. Then subtract 6, which gives me 6w equals 3. Then divide by 6, this gives you w equals a half, or 0.5. Question 4, part D. Solve this equation. Now it looks difficult because you've got 3 different denominators, 4, 3 and 2. There are lots of different ways of solving an equation like this. This is just one possible way of doing this. I'm going to multiply through by 4. The first fraction becomes 2x plus 3 as we cancel out the divide by 4 in the denominator. The second fraction, we can just write 4 lots of x minus 6 over 3 equals 3 over 2 multiplied by 4. So the second term, the second fraction has been multiplied by 4, and the right-hand side has also been multiplied by 4 as well. We're now going to multiply by 3, which is this denominator here. This first term then becomes 2x plus 3. The second term stays as 4 4x minus 6 because we cancel out the divide by 3 in its denominator, and on the right hand side we'd originally multiplied by 4, we now multiplied by 3 as well. We can then start simplifying and expanding brackets, so this first term becomes 6x plus 9. The second bracket expands to give us 4x minus 24, and then on the right hand side, if we work out what we get here, let's make that 4 over 1, 3 over 1. We know that to multiply fractions together, we multiply numerators together. 3 times 4 times 3 gives us 36. Denominators, 2 times 1 multiplied by 1 again gives us 2, so 36 over 2, which we also know is 18. On the right hand side, we are done. On the left hand side, collect the like terms. So 6x plus 4x gives us 10x. Then 9 minus 24, remembering that everything owns that sign that comes in front of it, gives us negative 15. Then add 15 to both sides, giving us 10x equals 33. Then divide by 10, which gives us x equals 3.3, or 33 tenths as a fraction. Question 5, part A. Expand this bracket. So 3 multiplied by x gives us 3x, 3 multiplied by 5, and it's positive 5, gives us positive 15. Part B, factorise this expression. We need to look for common factors here and here. 6a and 9 both have 3 as a common factor. Take it outside the bracket. We then have to think, what do we multiply 3 by to make 6a? It's 2a. What do we multiply 3 by to make negative 9? It's negative 3, and here is the factorised answer in green. Question 6. A rectangular carpet is 7 metres wide and 8 metres long. A square piece of side length x metres is cut from one of the corners. This is this part here. Dean works out the area of the remaining carpet in terms of x. His answer is 56 minus x squared. We have to explain how he obtained this expression. So, making our working very clear, the area of the whole rectangle before anything is cut out of it is 8 multiplied by 7, which is 56 metres squared. The area that we cut out is equal to x squared. It's x multiplied by x. So the area that's unshaded, i.e. the remaining area of the carpet, is 56 take away x squared. And we need to make all 3 of those steps very clear. 6 part B. Lucy also works out the area of the remaining carpet in terms of x. Her answer is x bracket 8 minus x plus 8 bracket 7 minus x. We have to use the diagram to show how she might have obtained her expression. Now, Lucy has divided the shape into 2 portions. If I draw in this dotted red line here, she's divided it into section A and section B. Section A, which we will outline part of in red there, has a length here of 8, and then this part here is 7 minus x, because the total side length from here to here, this part here, is 7 metres. If you take just this section from there to there, that part is 7 minus x. At the top section, this part here, B, the distance from there to there is 8 take away x, and this part from here to here is x. So area A is equal to 8 multiplied by 7 take away x, and area B is equal to x multiplied by 8 take away x. So the total area, unshaded, is x multiplied by 8 take away x plus 8 multiplied by 7 take away x, i.e. area A plus area B. Question 7, part A. Expand and simplify this expression. So taking each part in turn, we have 6x minus 4 plus 4x plus 20. Collecting like terms gives us 10x plus 16. Part B, solve this equation. Now we don't have to repeat all of our working. We know that this expression simplifies to 10x plus 16 on the left-hand side. This is now an equation which is equal to 0, so subtract 16 gives us 10x equals negative 16, and divide by 10 gives us x equals negative 16 over 10, which as a fraction is negative 8 over 5, and as a decimal is negative 1.6. Question 8. Multiply out and simplify this pair of double brackets. So starting here, 2p multiplied by 3p gives us 6p squared. Then we have 2p multiplied by q, which gives us plus 2pq. We then have minus 5q multiplied by 3p, which gives us minus 15pq. Keeping terms in alphabetical order can make simplification easier later on. Then finally, we've got minus 5q multiplied by q, which gives me minus 5q squared. We can then collect the like terms, 6p squared. The central two terms here simplify to give us minus 13pq, and at the end we've got minus 5q squared. Question 9, part A, expand this expression here. This gives us 3x plus 15. Part B, factorise 6a minus 9, which is 3 bracket 2a minus 3. This is also the same as question 5, so there is no excuse for getting this one wrong. Question 10, expand and simplify this set of brackets. Now we notice here that there are 3 brackets. Start with the first pair of brackets, so x plus 2 multiplied by x minus 3. Now we can see this will give us x squared minus 3x plus 2x, and then at the end minus 6. Let's simplify this, so it's x squared minus x minus 6. We then have to take this result and multiply it by the final bracket, x plus 1, and we do this in neat stages. So x squared multiplied by x gives me x cubed, x squared multiplied by 1 gives me an x squared. Then I've got negative x multiplied by x, which gives me negative x squared, and I write it underneath the other x squared term, so it's easy to then collect like terms afterwards. Finally, negative x multiplied by positive 1 gives me a negative x. Lastly, I have negative 6 multiplied by x, which gives me negative 6x. Again, I write the x terms in a vertical stack together, and negative 6 multiplied by 1 gives me a negative 6 on its own at the end. I can then simplify and collect all my like terms, working down like this. So I have x cubed. Now my x squared and my negative x squared will cancel here and here, leaving me with no x squareds. Then I have negative x minus 6x, which gives me negative 7x, and I have a negative 6 at the end. Question 11, part A. Factorise this expression. Now, this is a harder expression to factorise because there is a number, i.e. 2, in front of the x squared. So we have to remember all of the different stages of this. The first thing that we need to do is multiply together the 2 and the positive 1 at the end, which gives us 2. We now need to find two numbers which multiply together to give us this 2, and which add together to give us the positive 3 from the central term here. Now, there is only one combination of numbers that will do that. 2 multiplied by 1 is 2, 2 add 1 is 3. Now, setting out our quadratic again. The first term is 2x squared, the last term is positive 1. We now split this middle term of positive 3x into positive 2x and positive, if you like, you can do positive 1x, or you could just do positive x. It doesn't matter at this stage whether we write positive 2x plus x or whether we write plus x plus 2x. We can do that in either order. We then take these first two terms and factorise out the 2x, so 2x bracket x plus 1. Now we know that this x plus 1 is going to be repeated as a factor over here, so we write it down, x plus 1 again, and then we look at the second pair of terms. Now, in front of this x plus 1 over here, we need to introduce a plus 1 so that the bracket expands to give us a positive 1x and a positive 1 up here. We then have everything we need for our final factorisation. The x plus 1 becomes a bracket and is joined by the 2x and the plus 1 from up here. Here's another example of factorising a harder quadratic. There's a 4 in front of the x squared, which, as we know, will make the factorisation harder. I'm going to start off by multiplying the 4 and the negative 5, which will give me negative 20. I then need to find two numbers which multiply together to give me negative 20, and which add together to give me the middle value here, which is positive 19. Now, there is only one pair of numbers which will do that. Sometimes you have to think about these for a little while, but 20 add a negative 1 will still give me positive 19, and 20 multiplied by a negative 1 will give me negative 20. I then write out my quadratic. My first term is 4x squared, my last term is minus 5, but instead of plus 19x, which was originally the middle term, I'm now going to write out plus 20x minus 1x. I then take the first pair of terms and I factorise them completely, so I take a 4x outside the bracket, leaving me with an x plus 5 inside the bracket. Now I know that this is going to appear in the second half as well as x plus 5, so I write it down again. But if you look above, we've got a negative 5 and a negative x, and in this bracket here we have an x and a positive 5, so I need to place a minus 1 in front to make it work. Then, to complete my final factorisation, I have one bracket which is x plus 5, and then my second bracket contains the 4x from here and the negative 1 from there. Part C of question 11, hence solve the equation 4x squared plus 19x minus 5 equals 0. The fact that the word hence has been used means that something in the previous part of the question will help us solve this equation. Now, in the previous part of the question, we factorised 4x squared plus 19x minus 5 equals 0, and we did it as the following. 4x minus 1, x plus 5. Now, we know that we then make each bracket equal to 0 in turn. So if 4x minus 1 equals 0, 4x equals 1, x then equals a quarter. That's one possible answer. The other possible answer comes from x plus 5 equals 0, which is the second bracket. X then equals negative 5. So our two answers are these here. Part D of question 11. Rearrange this equation and solve it. So the equation that we are working with is x squared plus x equals 20. Now the first thing to recognise is that this is a quadratic equation because its highest power is a square, i.e. x squared. Now, to solve a quadratic equation, one side must be equal to 0. At the moment, we have 20 on that side, so we are going to subtract 20 from both sides. X squared plus x minus 20 equals 0. Now, we're going to solve this by factorising, so we need to find numbers to fill two brackets with. We have an x and an x at the start. The numbers at the end, which go here and here, must multiply together to make negative 20 and add together to make 1. because it's just x in the central term, we can imagine that there is a plus 1 in front of it. Now, the only pair of numbers that will do that is plus 5 minus 4. We can then solve this by taking each bracket in turn and making it equal to 0. This then gives us x equals negative 5, and the second bracket then gives us x equals 4. Question 11, part D, part 2. We have this equation, 2x squared minus 4x equals x plus 12. Now again, this is a quadratic equation. Notice the highest power of x is x squared, but it's not equal to 0, so we have to subtract an x and subtract a 12. This makes the left-hand side 2x squared minus 5x minus 12, and the right-hand side becomes 0. We've done 2 steps here in 1. We now need to try and factorise the left-hand side, so we're going to use the process we used a few steps before. So I'm going to take this 2 and this negative 12 and multiply them together. 2 multiplied by negative 12 equals negative 24. I now need to find two numbers which will multiply together to give me negative 24 and which will add together to give me the negative 5, which is from here. Now, the pair of numbers that I need are negative 8 and positive 3. So I can now rewrite my quadratic. 2x squared is the first term, negative 12 is the second term, but instead of negative 5x in the centre, we can write negative 8x plus 3x. We then factorise the first two terms. I'll take out the 2x. This gives me an x take away 4. I write down my x take away 4 in the second part here. But of course, notice that we have a positive 3x and a negative 12, which is not what we have here at the moment. Now clearly we just need to place a plus 3 in front, and then this will expand to give us positive 3x and the negative 12 that we want. We then factorise, as we did previously, by taking that bracket x take away 4, and then in our second bracket we have 2x plus 3, where the 2x is from there and the plus 3 is from there. Now we aren't actually completely finished with this, because this was in fact an equation which was equal to 0, so we actually have to take each bracket in turn, make it equal to 0, so x take 4 equals 0, which then gives us x equals 4 as one possible answer, and then the second bracket, 2x plus 3 equals 0, which gives us 2x equals minus 3, which then gives us x equals minus 3 over 2, or negative 1.5. Question 12, part A. Calculate the perimeter of this sector. Now, the perimeter of the sector is made up of this radius here, which is 5 centimetres, this radius here, which is also 5 centimetres, and then this arc length here, which we have to work out the length of. So, if we remember that the circumference of the whole circle from which this sector has been taken would be pi multiplied by the diameter. The radius is 5 centimetres, so the diameter would be 10 centimetres. So the circumference of the whole circle is pi multiplied by 10, or 10 pi, leaving this in terms of pi. Then we can work out the arc length for 1 degree. This 10 pi is the allocation for 360 degrees, so the arc length for 1 degree would be 10 pi divided by 360. I'm going to leave it as 10 pi divided by 360 for the moment. Then the arc length for our sector, which is 40 degrees, would be 10 pi over 360, the allocation for 1 degree, multiplied by 40. Now, if we then work this out using a calculator, this equals 3.4906 ... So the total perimeter then equals 3.4906 plus 10, where the 10 comes from this 5 and this 5 here. This then gives us 13.490 ... which I'm going to round over here. It's 13.5 centimetres to 1 decimal place. So the total perimeter is 13.5 centimetres. Part B, we need to calculate the area of this sector. Now, the area of the whole circle from which this sector has been taken would be pi r squared, which is pi multiplied by 5 squared, which would be 25 pi. I then work out the area which would be allocated to 1 degree's worth, because, of course, this 25 pi is for 360 degrees. This would be 25 pi divided by 360, which we'll leave in that form for the moment. Then the area for 40 degrees would be 25 pi over 360 multiplied by 40. Now, if we wanted to leave our answer in terms of pi, we would then write 40 over 1, and we would attempt to simplify or cancel down these fractions. Now, 360 and 40 both divide by 40. 40 divides by 40 to make 1. 360 divides by 40 to give us 9. So the first fraction becomes 25 pi over 9, and the second fraction becomes 1 over 1, meaning our answer is 25 pi over 9 centimetres squared, which we can work out as a decimal. This is equal to 8.7266 ... which is 8.73 centimetres squared to 2 decimal places.